Dear students, welcome to s.mathguru classes. So our main discussion is partial differential equation of second order. So we start some problems, we solve some problems. Now we consider the remaining problems. So this problem solve del square z del x square minus 4 del square z del x del y plus 4 del square z del y square equal to 0. So in this problem, this is x square, we write d square. Del x del y we write d dash, and this is y square we write d dash square. The z equal to 0, where capital D means del x and d square means del x square, d dash means del y, and d dash square means del square del y square. We get this. Now auxiliary equation is, for auxiliary equation we putting d equal to m and d dash equal to 1. M square minus 4m into 1 for 1 square equal to 0. So where we putting d equal to m and d dash equal to 1 for auxiliary equation. This implies m square minus 4m plus 4 equal to 0. So if we solving this, we get m minus 2 whole square equal to 0. This implies m equal to 2. Whole square we get m equal to 2. So this is our roots of the equation 2. So roots are equal. If roots are equal, therefore the required solution is z equal to f1 y plus twice x f2 y plus twice x, and this is our final answer. If roots are equal, then we write f1 y plus twice x and extra x we get f2 y plus twice x. This is the answer. Very easy solution. Next we consider another problem. Del to the power 4 z del x to the power 4 minus 2 del to the power 4 z del x cube del y plus 2 del to the power 4 z del x del y cube minus del to the power 4 z del y to the power 4 equal to 0. Now you want to solve this problem. This is del to the power 4 del x to the power 4, we have d to the power 4, and this is 2 x cube, we write d cube, del y we write d dash, 2 this is x, we write d, del y cube we write d dash whole cube, and y to the power 4 we write d dash to the power 4, z equal to 0. We get this. Just putting x to the power 4, we write del d to the power 4, this is x cube d cube, this is dash, and this is y cube d cube dash, and this is d, and this one d dash to the power 4. Now auxiliary equation is m to the power 4 2m cube into 1 2m, this is 1 cube 1 to the power 4 equal to 0. Just putting d equal to m, d dash equal to 1, d equal to m, d dash equal to 1. So we get this one, m to the power 4 2m cube plus twice m minus 1 equal to 0. So this is m to the power 4, it has 4 roots. So for solving this problem, this is difficult to factorize. At that time we using factor theorem. Last term is minus 1 given, So minus 1 means 1 into minus 1. So if we putting here 1 1 to the power 4, 2 into 1 cube plus 2 into 1 minus 1. This is 1 minus 2 plus 2 minus 1, this is 0. This one 0 means we get m equal to 1, this is the factor of this. Therefore, m minus 1 is a factor of this one, m to the power 4 minus 2m cube plus twice m minus 1 equal to 0. Now we divide this one by m minus 1. If we divide m to the power 4, 2m cube twice m minus 1. So our requirement m to the power 4, but we have m. So write down m cube. This and this, m to the power 4, m cube. This is 0, this is m cube twice m minus 1. Now next putting minus m square, this and this, minus m cube plus m square. So this is minus m square plus twice m minus 1 minus m, if we putting, then minus m square and minus m square plus m we get, and this minus this, m minus 1. If we putting 1, then we get m minus 1. So we get, so this is our rule. If we unable to factorize, then we using this factor theorem. So first we collect the last number constant. This is minus 1. Minus 1 means 1 into minus 1. So this will be 0 by putting 1 or minus 1. So first putting 1. Here we putting 1, m to the power 4, this we get 0. That means by putting 1 we get 0, then we write here minus 1. M minus 1 is a factor of this. Then if we divide this 1 by m minus 1, we get remainder 0. So what we get, therefore this can be written as m minus 1 into, so dividend equal to divisor into quotient plus remainder we know. So this will be m cube minus m square minus m plus 1 equal to 0. So this implies m minus 1, and this is m square common, then m minus 1. From this 2 minus 1 common, then m minus 1, this equal to 0. So m minus 1 remains same, and from this 2 m minus 1 common, we get m square minus 1, this equal to 0. So m minus 1, and from this we get a square minus b square formula, a plus b into a minus b equal to 0. So we get, this is the factorization. So obviously this will be m equal to 1, m equal to 1, m equal to minus 1, m equal to 1 we get. So three roots are equal, one is unequal. Therefore the required solution is z equal to f1 y plus, this is first you consider unequal, this is minus 1x plus f2 y plus 1x plus x, f3 y plus 1x plus x square f4 y plus 1x. We get this. How many 1? 1, 2, 3. So we write first is minus 1 we write here. Next 1x, extra factor we get x, 1x and x square we get. This one we get. Now finally we get z equal to f1 y minus x, f2 y plus x f3 y plus x square f4 y plus x, and this is our final answer. Very nice solution, very easy solution. Now we consider another problem of the same types. So solution, this one given, solve the linear partial differential equation del square z del x square minus 2 del square del x del y del square del y square equal to 0. So this can be written as d square minus 2 d dash plus d dash square z. This one we get. So this is x square, we write d square, and this is dx del x del y, so d dash del y square, then d dash square. So where capital D means del x and d square means del square del x square, and d dash means del y, and d dash square means del square del y square. We get this. Now auxiliary equation equal to, when we write auxiliary equation, that putting d equal to m and d dash equal to 1. So this equal to m square 2 into m into 1 square equal to 0. So putting, for finding auxiliary equation, I putting d equal to m, d dash equal to 1. So here d dash is 1, this is 1, and d means m. This implies m square minus twice m plus 1 equal to 0. This is m minus 1 whole square equal to 0. So we get m equal to 1 comma 1. Two roots we get, but both are equal roots. These are. So therefore the required solution is z equal to we get f1 y plus 1x plus x f2 y plus 1x, or we can write z equal to f1 y plus x f2 y plus x, and this is our final result. These are very interesting, very easy, very important also, and these are for engineering courses we get. Either it may be second semester, it may be third semester, but these are important for engineering courses and BSc major also. So I hope you are all enjoying with me. If you are all enjoying with me, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.